In the previous lessons, we learned how to take our given and multiply to two different conversion factors in the right order to convert between mass and represented particles. And represented particles are atoms, molecules, and ions. To simplify the process, we use drag and drop. Well, in this lesson, you are going to type in your answers. So let's read the problem again. How many molecules of calcium carbonate, CaCO3, are there in 30 grams of calcium carbonate? So you know that we are looking for molecules. That is our unknown. And we are given, notice how we are given exactly 30 grams of calcium carbonate. That is the given clue. And we are given two conversion factors. 1 mole of calcium carbonate is equal to 100 grams, 0.09 grams of calcium carbonate. Then we also have another conversion factor. 1 mole of calcium carbonate equal to 6.02 times 10 to the 23rd molecules of calcium carbonate. So let's look at the solving strategy. Again, we take our given time conversion factors, one or more, until we get our unknown unit. In this case, it's molecules. So let's go back and type in our answer. We always start with a given. And what is the given to us? 30.00 grams. And we use G. So calcium carbonate, CO3. Isn't that easy? Now that's our given, times the first conversion factor. But the question is, which conversion factor do we use? Well, here we have moles and grams. And right away, you know that we are going to use that one, but we're not sure. And here we have moles and molecules. So if we look at this right here, we have grams right there. So our conversion factor must have grams in it, especially grams of calcium carbonate. So if this is a gram of calcium carbonate, we need to cancel that out. So therefore, the grams of calcium carbonate go on the bottom. So what we have here is exactly 100.09 gram, which is represented by G, calcium carbonate, CO3. And if the grams of calcium carbonate is on the bottom, the top part must be 1 mole of calcium carbonate, because the conversion factor has two sides, one on the left, one on the right, and they are equivalent to each other. So we have 1 mole of calcium carbonate. Notice how grams of calcium carbonate cancel out with another grams of calcium carbonate. Now we are done with that conversion factor. If that cancels out, we have mole left. And notice how this is mole of calcium carbonate. So therefore, this must be mole of calcium carbonate as well. Exactly 1 mole of calcium carbonate. And that is coming from here. And if this side is on the bottom, the other side must be on the top. So we have 6.02. And remember, we use E to represent 10 to the power of something. In this case, 6.02 E 23rd, that's pretty much 6.02 times 10 to the 23rd. So E 23, and we're going to write out molecules of what? Calcium carbonate. Now let's use our Google calculator to type in and solve our problems. And again, we are going to multiply every numbers on top divided by every numbers on the bottom. So what do we have? We have 30.0, okay? And that is being multiplied by what? 1. So we have that multiplied by 1. And then we are going to divide by that number on the bottom. And again, 100.09, okay? And multiply by that number on top, which is 6.02e. So what is e again? 6.02e. Well, that e right there is also equal to the exp button on your calculator. And that turned out to be 23 and divided by 1. 1.80 e 23rd. That means 1.8 times 10 to the 23rd. But we are going to type in 1.80 e 23rd. Well, in this case, what's the unit that's left? Molecules of calcium carbonate. Then we are done. Now that we have shown our work online, the next step is how are we going to write this work on your paper? Well, think of this like fraction. So what we have here is a fraction, okay? Remember, conversion factor is just a fraction. So we have 30.00 grams of calcium carbonate times that fraction. So we have 100.09 grams of calcium carbonate. That's on the bottom. And on top we have 1 mole of calcium carbonate. And look at that. That cancels each other out, right? Now we have moles of calcium carbonate. Multiply to the next conversion factors. If that is mole, that must be moles on the bottom as well. And calcium carbonate, notice how they cancel each other out. And we have 6.02 e to the 23rd. And that would be molecules of CaCO3. Remember, E is equal to times 10 to the power of something, okay? And then our answer is 1.80 E 23 molecules of calcium carbonate. And that is how you show your work on your paper. Let's try another problem. How many grams of calcium are there? 12.04 times 10 to the 23rd calcium atoms. And notice how we are converting between mass in unit grams and represented particles again. But we are doing the reverse of it. And we are given 2 conversion factors in terms of between moles and grams. And we have conversion factor between moles and atoms. And let's look at this problem. We are again using the same strategy. Take our given times the conversion factors, as many as we needed to get to the unit that we are looking for, in this case grams. Well, eventually I'm going to give you extra units to confuse you and to trick you. Right now, I'm going to give you all the unit that you are going to use in this problem. And our given is 12.04 times 10 to the 23rd. And again, we use E to represent that. And again, we use E to represent 10 times something. So what we have here is 12.04 E 23rd atoms of calcium. That's pretty easy. Time our conversion factors, and which one are we going to use? Notice how this is atoms of calcium. So the conversion factor that we multiply by must have atoms of calcium in it. Well, this one have atoms of calcium in it. So therefore, that's the one. And we're going to have what? 6.02 e to the 23rd atoms of calcium. If this side is on the bottom of the fraction, this side must be on the top. So we have 1 mole of calcium. And notice how we multiply that conversion factor, and the atoms of calcium cancel each other out, giving us mole. So the next conversion factor that we multiply by must have mole of calcium in it. In this case, we have this one right here. And if this is mole, down here must be mole as well. So we have 1 mole of calcium. And that 1 mole comes from here. We just copy exactly from that side. And if this side is on the bottom, the other side must be on the top. So we have 40.0 grams of calcium. Then we are pretty much done. The next step is we are going to use our Google calculator, and we multiply every number on top divided by every number on the bottom. So we have 12.04. Again, E is represented by EXP 23. Multiply. In this case, we're going to divide by, well, multiply by 1 because that's on top, and divide by 6.02 e to the 23rd, okay? And multiply on top 40.08, backspace, 40.08, and divide by 1. And what do we have? We have 80.16. And what's the units left over? Well, atom will cancel. And what is the unit going to be? Well, grams of calcium. So we have 80.16 G calcium. And that's all we have to do. Now let's look at how are we going to write this on our paper. Well, remember, we are using this, and this is just fraction, okay? So the conversion factor is just a fraction. So we have 12.04. In this case, I'm not going to write E, but I'm going to try to write times 10 to the something, just to change the writing a little bit. So see that E right there? Times 10 to the 23rd atoms of calcium. On a computer, we type E, but on a paper, you can write any way you like. Time our first conversion factor, we have 6.02 times 10 to the 23rd atoms of calcium. Remember, this right here can be represented by E, okay? And that on top will be 1 moles of calcium. Times the next conversion factors, we have 1 moles of calcium on the bottom. And on top, we have 40.08 grams of calcium. And notice how atoms of calcium cancel each other out. Moles of calcium cancel each other out. And what do we have in the end is 80.16 grams of calcium. So this is how you show your work on your paper.